All right, this is our sets and logics. Logic Unit 5, which is all of your logical arguments. So talking about some of these, so you have what's called a logical argument, and that's that you have a set of premises, and the premises are what you're basing the conclusions off of. So if I say premise 1, all college professors have at least a master's degree, I can base a conclusion off of that. Dr. Jones is a college professor. Dr. Jones has at least a master's degree. So that conclusion, that Dr. Jones has at least a master's degree, comes from the two premises that were in pink. So all of them have at least a master's. He's a college professor. Therefore, he has at least a master's as well. So if the argument that follows from the if the argument represents a conclusion that has to follow, necessarily follows from the premises, we call that valid. Yeah, that's a little messy, sorry about that. If they don't have to, or they don't necessarily follow, that's called invalid. There we go. And then an error that causes that invalid argument is known as a fallacy. So the words I'm trying to write here are, we have, if the argument is valid, then the conclusion followed necessarily from the premise. If it's invalid, it didn't necessarily follow, meaning there could have been others. And if it's an error in reasoning that gives you an invalid, it's called a fallacy. There we go. Okay, let me clear that. I'm going to move down. So we have this note right here. And what it is it's not about what you think. If you think the argument makes sense, if you think the argument doesn't make sense, it's does it fall necessarily from the premise? So based on the premise, does that conclusion follow? Okay. It's not your personal opinion, none of that. And we go with, you assume the premises are true, and then decide if that forces the conclusion or not. Okay, so we have a couple laws that make valid arguments. And if you go back to that idea earlier where we had a statement, contrapositive, inverse, and so forth, we found that the statement and the contrapositive were both of the same truth validity or truth factor. So this one basically says that if P goes to Q, then P goes to Q. So that's similar to your original statement. So if the battery is dead, the cell phone will not work. The battery is dead, therefore the cell phone will not work. Okay, so it looks like the original statement. And it's that idea that P goes to Q, so P goes to Q. So then for the second one, it's the law of contraposition. I want you to think about that as a contrapositive. So what your contrapositive was if P goes to Q, then not Q goes to not P. And we had said earlier that they have the same truth value. So you're assuming that P goes to Q, therefore not Q will go to not P, because you assume these are true. So if I practice, then I will improve. If I did not improve, therefore I did not practice. So if you practice, you have to improve. You didn't improve, so you couldn't practice. So that looks like your contrapositive. And remember that in the original statement, P goes to Q, so not Q goes to not P, and they have the same truth value. So since we are assuming that the original premise is true, then that contrapositive also has the same. So if it looks like the contrapositive, it's also true, or it's a valid argument. I'm clearing that because I'm moving down. Hopefully you're able to pause me in time so you can grab anything you need. And then we have this law of syllogism. Think of this one as the domino effect. So P goes to Q, Q goes to R, therefore P goes to R as well. So you kind of cut out that middleman. If P goes to Q and Q goes to R, then P also goes to R. So if you text while driving, then you are driving distracted. If you drive distracted, then you're endangering others. Therefore, if you text while driving, you're endangering others. So if you text while driving, you are distracted. Therefore, you're endangering others. So again, think of that as the domino effect. Can I cross the middle one out? The conclusion is true. And these are all examples of valid arguments. Okay, and then the last one here is this law of disjunctive syllogism. And it has two ways you can write it. And I'm going to go straight to the example for a second. Natalie has to take chemistry or biology as her required lab science. There's nothing that says she can't do both. But she is being told this is required, you will take one. So this says if you have P or Q and you don't do one of them, you have to do the other. So if you have to take biology or chemistry, and you don't take chemistry, then you have to take biology. And the vice versa is true. So if you didn't sign up for biology, you have to take chemistry. So you promised to do P or Q. If you don't do P, you have to do Q to kind of keep that promise. Okay. So those are examples of valid arguments. So when you're proving if an argument is valid or not, you should be able to do one of these that actually shows that it really is. And I'm about to delete and go to the next page. And these are our fallacies. So remember, fallacies are going to be an error in reasoning that gives you an invalid argument. So all of these fallacies are our invalid arguments. Okay. Sorry, that's a little messy. Invalid. Arguments. Okay. And kind of remember when we were working on it, the converse and the inverse are logically equivalent, but they are not equivalent to the original statement. So in this example, P goes to Q. That's my original statement. But that doesn't mean Q goes to P. So if the battery is dead, the car won't start. The car won't start. Does the battery have to be dead, or can there be other reasons like the starter, out of gas? So it's not necessarily that premise that followed. Okay, and this looks like the converse. So this looks like our converse, which says P goes to Q, Q goes to P, and if we remember, not equivalent to original. So if you can remember what the four are, statement, converse, inverse, contrapositive, then you're going to do just fine, because those converse and inverses are going to be invalid. So the inverse stated, one second. That P goes to Q, not P goes to not Q. So you're negating both of them. And in which case that's also not true. It's not logically equivalent to the original, which is presumed to be true. So if you exercise, you'll lose weight. You did not exercise, therefore you cannot lose weight. Well, that's not necessarily true. You could do nutrition, you know, what you eat and whatnot. So that's not necessarily true. So again, we assume that the statement is true. And then if it looks like the inverse or converse, then it's a fallacy. If it looks like the contrapositive, it's valid. All right, excuse my bad writing. I'm trying to get used to the pen on these touch screens. Okay, so our next one then is fallacy of the inclusive or. Okay, and what this says For example, Jason will take psychology or sociology. Therefore, sorry, Jason took psychology, therefore he didn't take sociology. So what this means is this inclusive or, let me get my pen back out. Means you could take one class, the other, or both. Okay. So you could take both. So just because you took psychology doesn't also mean you can't take sociology. It just means you have to take at least one. Okay. So when you go through these, you should be able to say why an argument is valid or invalid. Not just that it is, but why. Okay, so now if we look at these are diagramming your different arguments, and you should be able to draw a diagram or a Venn diagram as well. So again, it's valid if the premises are true and conclusion follows logically. And if it doesn't, then it's a fallacy, but we are assuming the premises are true. So let's see. The premises are all cats are mammals. So if I were diagramming this, cats, mammals, and cats have to go inside of mammals. A tiger is a cat, and that would be my diagram. Therefore, it would make sense to say a tiger is now a mammal. So coming over here, mammals, all cats are mammals, so they go inside. And then a tiger is a cat, so there's only one spot to put the X. So if there was not very clear spot to put the X, then that would be a little bit different. So for example, if I come down to this one, all firefighters know CPR. So here's my CPR people. Firefighters are inside. Jill knows CPR. Okay, so Jill goes in the CPR circle, but are there other people that know CPR? Jill might be a nurse, Jill might be a child care provider, she just might know CPR. So from here, all we can conclude is that Jill knows CPR. We cannot conclude she's a firefighter because the X could go in the firefighters or in the CPR. Therefore, this one would be invalid. Okay, so in general, let's scroll down to our next page. So in general here, if you have the word all people, then they form a circle within a circle in the Venn diagram. And then this is everybody. So this might be all people. These are people with blonde hair. And then these are people all something, something. Then for some, it just means there's an overlap. So the sum part is right here. And the square is the universe. And then if you have none, that means they can't overlap at all. So those are examples of Venn diagrams. And in order for the argument to be valid, you should only have one spot to put your X. So over here, no cows are purple. So these are cows, these are purple things. Fido is not a cow. Fido is purple. So Fido could be here or in the purple. Therefore, this one is invalid. Fido could be quite a few things. Right, so I'm gonna erase this real quick. Go ahead and pause and work through a couple of these, trying with the Venn diagram or Euler diagram. And then we'll come back and go through and check your work. All right, so assuming you just paused me, all cats purr. All cats purr. So these are cats, these are animals that purr. Okay, and that's all we're asking for this one. Some students work full-time. So that some would be in here, meaning some John Tyler students don't, other people work full-time. You got a couple answers here. Some teachers are not in a union. Okay, so we can still write this the same way as teachers union. And this is just referring to that part, the teachers that are not in a union. And then the sad one, no candy is considered a healthy food. No. Here's my candy. Here's my healthy food. No candy. All right. So again, you should be able to explain why an argument is valid or invalid, past just saying valid or invalid. So pause. I'm going to clear this. All right, so what you want to do now is pause and go through and try a few of these. And then pause after each one and see if you can get the next one. So the idea is you're going to determine if they're valid, but not just if they're valid or not, but figure out why. So what you can do is a Euler diagram. How you know you want to use one of those is words like all, some, all. How you know you want to try to use the contrapositive or converse as if it has words like if, oops, sorry, if then, or it has, you know, not the sum, all, and whatnot, then we want to try to get another reason. So if I see that all models are beautiful, I'm going to start to make a Venn diagram. So these are my models. These are beautiful people. Some models are tall. Here's where it gets a little tricky. Some models are tall. So here's my tall people. They might be a model, they might just be beautiful, or they might just be tall. Some beautiful people are tall. Yes, it's right here. So this one is valid. It's also valid because of this part. So we do have that overlap that all models are beautiful. Some models are tall. So we do have a tall, beautiful model. Therefore, some beautiful people are tall. So that one was valid. Now we're going to do the other one, the second one, with our P's and Q's. Okay, so this is P, go to the movie, and go to the park. Whoops, go to the park is Q. Okay, if I can't go to the movie, then I will go to the park. Okay. I can go to the movie. So I will not go to the park. Okay, so let's rewrite this, where this P is actually just going to be a regular P. And the other one will be our, oh, I didn't mean to get rid of my Q. And the other one will be our negation, because that's going to help us figure this out. So I'm actually going to make P, I can't go to the movies. So can going to the movies is not P. Now this looks like something we know. This looks like an inverse, which makes it invalid. Okay, so changing the way you're looking at it can help make it seem like it makes a little more sense. All right, Julia will go to California or Florida. She did not go to Florida, therefore she has to go to California. So that's a valid. Oh, wrong one, sorry. That's valid. So she has to move to California or Florida. She didn't move to Florida, therefore she moved to Carolina. All right, pause if you need to. I'm going to clear this and move it up. Okay. Right now we can keep going with these. If you score at least a 90, then you'll earn an A. Diagramming these. You did not earn an A, therefore you did not score at least a 90. That looks just like the contrapositive, so that one is valid. Good time to pause and try a few. If you didn't do them thinking you needed to see a few more, this is a great time to pause. All right, some ARPs are bombs. ARPs, bombs. All bombs are creeps. Some ARPs are creeps. So even though that's very interesting to see, we've got this overlap here. So that one was valid. Okay, so our next one then is Jada will play soccer or softball. Okay, so she'll play soccer or softball. She plays soccer, but she does not play softball, which is invalid. That's that inclusive or. You can play both of them if you want. Okay, continuing on. All equilateral triangles are equal angular, and equal angular are isosceles. Okay, so here's equilateral. Here's equal angular. And then let's call this R. Here's isosceles. So all isosceles triangles are equilateral is now not true, because here's all the isosceles. Some are each of them. So that's an invalid as well. All right. I'm going to go ahead and clear my screen because it's getting a little messy. All right. If you work hard, you will succeed. If you work hard, then you will succeed. You work hard, you will succeed. Valid. That's the original statement. If it's the original statement, it repeats itself, we're good to go. Oh, here's the sad one. No candy is a healthy food. Ice cream is not candy. Therefore, ice cream is a healthy food. That one is invalid because ice cream could go still in the healthy food, but it could still be in unhealthy food. We don't really know which one it goes in. Okay. Again, I'm going to clear this so we can see the rest. Okay. If you drive recklessly, you will get into an accident. You got into an accident, therefore you drove recklessly. Okay, think about this one for a second. This looks like what? The converse. We've just flipped it. Okay. Are there other reasons you could get into an accident? Absolutely. You don't just have to have been driving recklessly. There are lots of other reasons. So this one is invalid. And finally, if you take math, ooh, this is a good one, you'll have, whoops, that'll mess us up. If we take math, we will have good problem-solving skills. If you have good problem-solving skills, you'll excel at any career. Drop the middleman out. If you take math, you'll excel in your career. This one is valid. It's that domino effect, law of syllogism. So just keep that in mind. All right, clearing it for the next page. What I have on this next page is this is going to be all of your different logical fallacies in common language. So what you'll want to know on these is you'll want to know each of them. And then if I give you an argument, you need to know you need to know which one it is. So pause, read through all those, and then I'm going to work through the examples. So here would be an example of what we would expect on a test. If you have a certain logical fallacy, you would be able to figure out which one it was. So in terms of this, I want you to go through and just see what you can match up first based on what you just read, and then we'll go ahead and go through them. So for question 1, your answer was D. This was an appeal to consequence. So if I go back on this page, appeal to consequence was that you appeal to basically what I think of as the conclusion or whatnot based on whether it's desirable or not necessarily if it's logical. Let me line these back up. Oh, there we go. So this is my last course before I graduate. I won't be able to transfer if I don't pass. Please give me a passing grade. There's no actual logic in that. So it's what we call a logical fallacy. Number 2 is H. This is the actual straw man. Candidate 1 hates our country. Basically, think about it like you're going through a fake, straw man to attack. You're not doing anything necessarily for the argument. 3 was I. Okay, so this is a common misconception that a correlation, which is a relationship, implies causation, which is not necessarily true. So you see a teenager you didn't recognize walking down the street. That same night, the car was broken into. So you're assuming that because you didn't know him, he has to be the culprit, which is not true. 4 was E, which is false dilemma. False dilemma is where you're given basically a false dilemma. They say you have to do this or this, when in reality, that's not true. So you either support funding the troops or you don't care at all. Well, that's not true. There's a lot of middle ground there. 5 is A, which is ad hominem. And that's where you're attacking the actual man. He couldn't even keep his company out of business, blah, blah, blah. 6 is going to be C, which is appeal to authority. 9 out of 6 dentists recommend our toothpaste. Clearly, it's the best. Think of that kind of as the talking head, a celebrity endorsing something like that. And then 7 is G, which is post hoc. The copier worked fine before she used it, so she must have broken it. And that's where an event happened, and then the next one you're blaming. 8 was B, which is appeal to ignorance. Because we've never seen life on other planets, must not exist. And 9 was F, which is circular reasoning. That professor was wrong to give me a C in his class. I'm an A student. So what circular reasoning is you're going for the conclusion first. I am an A student. Therefore, the professor was wrong versus the other way around. So read through those, see if you have questions, match them up, try them a few times, and that's it.